Hi, I am Atanu. This tutorial video we learn the radicals of the irrational numbers. So this is continuation of the class 9 chapter 1 math number system. Okay. So first we learn what is radical. What is radical? So radical is the expression that contain a square root. So what that mean if there is a square root symbol, then we can say it is a radical. And also the there should be the n square root also. Okay, for example, if I put here n also, then you can say it is radical. So whatever values we can represent like this, actually it is all are the irrational number. Okay, so if it is a perfect square, then we can't say it is a radical. Okay, so mostly it is represented by the irrational number. Clear? For example, uh, so these all are symbol. For example, if I put in place of the n is actually 3 something, any value, or here it is 2 is it is not required actually. Okay, it is not required. Clear? Other numbers consider as 5. Okay, so when there is a symbol of the square root or n square root, then we can say it is the radicals. Okay, is it clear? Now we learn order of the irrational number. So we know that if we write n root of a, then it is a we can say it is a irrational number. Okay, where n is actually, if it is the irrational number, then n is actually say it is a order. Clear? For example, if I told you what is the order of this number, irrational number root 2, you can say order of this irrational number is equal to 3. So this part. Clear? So this part. Okay, now we learn the different laws of the radicals. By applying these laws, we can simplify the irrational expression. Okay, so first is uh, just a minute. The first law is if n root a to the power n, then we can write as, just a minute, we can write as n root a to the power n, and also we can write as a n, okay, into 1 by n. Actually this part is actually laws of indices or exponent or power. Clear? So this is the laws of the irrational number. So this part you can say the laws of irrational number, this part. Clear? And this part laws of the indices exponent power, and we use mostly this part actually. If the question is like this, then you convert into this to simplify further. Okay. And finally we get what? Finally we get, this is cancel out, so we get A. Clear? The second law is what? Second law is n root A n root B, since here the aim base actually not same, but root means order is same, so we can write as, so order is not yes, order is same, so we can simplify this like this. But from where we get it? So this part if we convert into the indices form or of the exponent form, then what we will get? A to the power 1 by n into b to the power 1 by n. Clear? So we get, since it is power is same, but base is different, so we can club the base and take the common power. Okay, 1 by n, and it mean actually root n root ab. That is the reason we get this value. So we can remember into the exponent form or the indices form. Actually this part is very much easy to remember, but this part having some confusion. Okay, this part is confusion. But if we convert into this from here directly, then easily we can remember this, because from here we can write down as the this part. Clear? From here we can easily convert into this part. It is easy, right? So this is very easy to remember. What is the next? The next is when the base is actually same, m and n, but power is different, then what we can do? We can multiply the power root here, or we can change the position also, means we can change in position also and m inside also, then also get the same value. But it is very easy to remember if we convert into the exponent form, right? So first we write the inside part, that is a to the power 1 by n, then it is again m root, so we can do the 1 by n power 1 by m. Now we know that a to the power n into 1, this power by power over power, actually we can multiply it. Okay, that is mn. Clear? So obviously this part actually very easy to remember. This part is easy to remember. Is it clear? So next we learn when for the division, when the power is same but base is different, means also the root is same a, and this means order is same. For the irrational form or the radical form, then we can write as again this part easily we get from this uh, exponent form, that is this top part, what we will get, a to the power 1 by n, and bottom part what we will get, b to the power 1 by n. Now we know that if base is different but power is same, then we can write as 1 by n. So from here we easily convert into this. From here we can easily convert to this, correct? Means if we get this form, then you can convert into this, then simplify this. Okay, then we can convert again into the radical form, correct? Okay, next is fifth law, that is it is little bit complex. Here root m, here root m, and then it is what, it were p, and again it is m, correct? So what you can do, look at this part actually you can simplify from the exponent form, clear? But before that it is not possible to remember, but here you must remember, if there is a power of m, then we can write as m, and p, a to the power p at power m, then we can write as a to the power pm. Okay, or no, it is not like that. We can do the calculation. It is directly we can, that it is m and power m, so it is cancel out each other. We already know that, we have already learned. Okay, it is cancel out, means you must remember every time that if something a is there and here is m, sorry, it is not visible, right? And here is m and here is m, then we can write as what, a to the power m to the power 1 by m, correct? Means power, it is power 1 by m, so it is cancel each other, then it become m. So if root m and a to the power m always become a. Okay. So what we will get, n, and here it is a to the power p, and also from the radical from the exponent form also we can easily find out that it will be what, m a to the power pm, then n a to the power pm into 1 by m, so cancel out, what remain, m a to the power p, correct? So we get this same value, clear? Okay, so these are the laws. Now take one example how we can apply this radical as well as the exponents laws, okay, together to simplify any uh, irrational expression. Okay, let's take one question, uh, that is root 3 root 64. So just I follow the two method. First method is actually what we can do, we know that if factorize this one we get 8, so here is how much, so total is how much, total is the 3,336. Okay, so we get the 2 to the power 6. Okay, 64 is 2 to the power 6. Correct. Okay, now what can I do? From the radical by applying the radical rules, what we can do, that is 3, and here it is 2 to the power 6. Now we can apply these rules. Okay, so if the base is same and there are the two roots with the different uh, uh, different order, we can multiply the order m into n. Okay, so actually it is not that much easy. Okay, so next what we can do, so uh, here actually 2 is there. Root, without root means what? Without root means actually something root means actually there is a 2. Actually we do not consider, no need to write this, okay, this portion we never write, but it is already there. Okay, so what we can do, so we can, sorry, what happened, we can apply these rules. We get 2 into 3 root 2 to the power 6, and you get 6 to the power 6, and again we can if it is 6 and here it is 6, then it will be the 2 is the right answer. But we can apply the exponent rule. Okay, so by applying the exponent rule, this is the radical rules, this is the radical, this rule we apply. Okay, uh, this is the radicals law rules we apply, but here we apply the exponent law. Okay, right side is same problem we can solve with the exponent law. This person, how you can do that? Let's solve it. 364. So next what we can do, you know that 64 we can write as 2 to the power 6, is very easy. Then you just remove this root, so what we can do, by 3, then this is 2, and we know that inside it is a perfect square, then you get the 2 is the answer. So this actually this method is most easiest method, so better you follow this method. And if you are confident with the radicals rules or all these formulas, and it is not too much easy actually to remember all these things, and little bit confusing also, so better this YOLO part, means the exponent laws we can or the indices laws we can apply to get the same result quickly without any headache. Clear? Let's take another question, how easily we can solve it. Okay, for example, just a minute, another question, one question, that is what is the question, x y z the positive real number, x y z positive real number, prove that root x to the power minus 1 into y, okay, or you can write this uh, root x into y, okay, multiply root y into z multiply root z into x is equal to 1. So let's solve this question by uh, applying the exponent rules. Okay. So first write the question, that is root x y into root y z into root inside, actually these are inside, sorry, these are inside root z into x, okay. Next, sorry, we write as the exponent form, it will be very easy to solve. So first step will be minus 1 y into y minus 1 z into z minus 1 x, okay, clear. Then we can uh, write as y by x into y by z into sorry, y by z na z by y z by y z by y, and here it will be x by z, clear. The next steps will be y by x to the power minus 1 into z by y to the power minus 1 and x by z to the power minus 1, clear. The next step will be what? Uh, since the base is different but power is same, then we can multiply each other, xy zy into xz, clear, to the power minus 1. So here what we can do, this y cancel out, x cancel out, z cancel out. So finally we get what? 1 to the power minus 1 means 1 is the right answer, clear. So most of complex problem can be uh, solved with the exponent rules, not the radicals rules. So it is up to you. If you are confident, all this all these laws of the radicals and formulas you can remember easily. I think it is not that much easy to remember. So better you apply this, convert, if the question given the all irrational forms, the radical forms, you convert it into the uh, exponent form, then you simplify it and you get the result very quickly without any doing mistake, correct. Let's take another example. This is the question. The question is just a minute. The question is just a minute. Okay. The question is x to the power a by x to the power b by 1 by ab into x to the power b x to the power c 1 by bc into x to the power c by x to the power a 1 to the power ca is equal to 1. So by uh, applying the indices or the power or exponent rules, we can solve this. Can simply solve this. So let's start the solution. How you can do that? Okay. So we know the all rules of the exponents, that is here x is there. So first we write the question for a b to the power 1 by ab into x to the power b x to the power c to the power 1 by bc into x to the power c by x to the power a into 1 by ca. So this is the LHS. So next what? Next is since the base is same and power is different, so it will be 1 minus a minus b. Okay, and ab x to the power b minus c 1 by bc into x to the power c minus a to the power 1 by ca. This is the a. Okay, next this power, and again it is power, so we can multiply the power, we know that. So a minus b by ab into x b minus c by bc by bc into c minus a by ca. Clear? Next what we can do? X to the power, this base is same and power is different, so we can add all the power. Okay, why? We know that a to the power m into a to the power n, if we multiply to, we can add the power, we know very well. Okay, so what we can do here? a minus b by ab plus b minus c by bc plus c minus a by ca. So LCM is what? ABC. So ca minus b plus ab minus c plus bc minus a. Clear? Next is what? Next is x ca minus cb plus ab minus ac plus bc minus ba. So ab ba, it is a. Okay, this is all cancel out, this is cancel, and bc what? cb bc both are same, this is cancelled, and ac ca is cancelled, and numerator actually got the 0 value, and here it is abc. So x to the power 0 by abc, so x to the power 0 is 1 is equal to RHS. See, so you have to follow this step. It is not that much difficult if you practice, and then easily you can solve it yourself. Okay, clear? So this is the end of this video. Thank you for watching this video till end, and also this is the end of this first chapter, class 9 number system. And after completion this entire series, if you watch the all video thoroughly, and I am sure that you can solve the exercise yourself, and this is my little effort to make the quality education to everyone. Okay, so if you have any doubt, you can comments below, and also you can send a message to my WhatsApp and Telegram channel also. You can join there, and I take the online class for the advanced training and test. and your doubt clearance, one-to-one communication. Please like this video and share with your friends to grow this channel. So I'll be very appreciate all of you, and this is my little effort, and if you appreciate, then I can able to upload the more videos, and it will be very easy to understanding and to everyone. Okay, thank you very much. See you in the next chapter video. Okay, bye.